Welcome to Engineers Mindset. So let's say we have this problem on the board and we are asked to find the reactions at the fixed support, which is at point A. Alright, so first of all, this is a cantilever beam. A cantilever beam is simply a beam that is fixed at one end. Okay, in most cases, it can be fixed also at both ends. But in this case, we have this cantilever fixed at point A. Now, first of all, before we can be able to do any analysis on this, we have to outline the free body diagram. So FBD. All right, so we'll simply bring back the beam. For a cantilever beam, please take note, for this fixed support, there are three reactions that occurs at the fixed support. One reaction is vertical, one reaction is horizontal, and then we have a moment at that point. So we have a vertical reaction at the fixed point, which is called is RAY. We also have a horizontal reaction called is RAX. This is point A. Then we'll have a moment. Okay, so call this moment MA, all at point A. So these are the three reactions that takes place at the fixed support of every cantilever. Three reactions, one vertical, one horizontal, and then a moment or a couple. Okay, now between A and B also we have a uniformly distributed load, the UDL, and the length of the UDL is 2. So we need to convert the UDL also to a point load. To convert the UDL to point load, like always, multiply the intensity of the UDL to the length. The length of this UDL is 2 meters. Therefore, the intensity also is 10 kilonewtons per meter. Therefore, the point load becomes 10 times 2, and that is simply 20. Then I said, placing this point load, you place it at the middle of the length covered by the UDL. The length of the UDL is 2 meters. Middle of 2 is simply what? 2 divided by 2, and that is 1 meters. So which means we have this UDL to have a point load here, and the point load is simply 10 times 2, which is 20 kilonewtons. Now, distance from point A to the point load is 1 meters. Okay, this distance from the point load to point B is simply 1 meter. So this is point B. So the UDL load now, point load, have to act at the middle of the length. Okay, finally we have a 10 kilonewtons load at point C. Okay, all right. So the question is for us to determine what the reactions at A or at the fixed point. First thing to do is to employ your equilibrium equation. Recall summation f of x from equilibrium law is equal to 0. So which means sum all the horizontal force and equate them to 0. The only force pointing in the x-axis here is simply RAX. So this simply means that RAX is equal to 0. That's the first reaction determined. Next is summation f of y. Summation f of y equals 0. Let's consider vertically upward force always as positive, downward force always as negative. So we simply have RAY, okay, pointing upwards, so it's positive. We have 20 kilonewtons force acting downwards, so it's negative, minus 20. And then we have 10 kilonewtons force at point C acting downwards, so it's negative, minus 10. Okay, that's the only reaction force we have there. So the whole of this is simply equal to 0. Of course, RAY minus 20 minus 10 is simply minus 30, and that's equal to 0. Now simply send minus 30 over to this side of the equation. We can find the value of RAY. So that simply means RAY is equal to 30 kilonewtons. So negative sign crosses an equal to sign becomes positive. So you have RAY to be that 30 kilonewtons. The next reaction to find is moment at point A. To find this moment, you have to simply take moment of forces about any point on the beam. Now, I always say take moment about the point where you have numerous of forces, so that the moment of those forces at that point becomes 0. Since we have unknowns here, okay, since we have two forces here, RAY and RAX at point A, simply take moment at point A. So you take moment at point A, take moment at A. Okay, so summation of the entire moment at point A is equal to 0. We'll consider clockwise moment to be positive and anti-clockwise to be negative. So you have this. Now remember that at point A we already have a moment clockwise. So MA is there already, so it's positive. Simply bring it down, MA. Also, the moment of these two forces, RAX and RAY, about this point becomes 0. Next, we take moment of the 20 kilonewtons force about point A. This force is pointing downwards, so it will turn in this direction, which is what? Clockwise. That's positive to our direction. So it will turn in this direction. And distance it takes this force to get to point A is simply 1 meters. So you simply have plus 20 times 1. Finally, you have 10 kilonewtons force also pointing downwards. So distance it takes this force to get to point A is simply, remember, from B to point C is 1 meter. So from here to this point is 1 meters. So it takes 1, 2, 3 meters to get to point A. And since it is acting downward, it goes all the way or turning about this point, which is also positive, that's clockwise. So we simply have plus 10 into 3. And the whole of this is simply what? 0. So you have this. Therefore, moment at A plus 20 times 1 is 20, plus 10 times 3 is 30. That's equal to 0. Moment at A, 20 plus 30 is simply 50, plus 50 equals 0. So let's send plus 50 over to this side of the equation. We simply have moment at point A to be equal to minus 50 kilonewtons meter. So please take note, you have negative sign doesn't mean you're wrong. It only means that the direction we assume for the moment is wrong. So which means this moment at point A is actually what? 50 kilonewtons meter, but in the anti-clockwise direction. So you simply have this. Okay, so those are the reactions at point A, and that's how you're going to find these reactions at point A. All right, guys, I hope you enjoyed this wonderful video. Please, if you do, I would like to hear your thoughts in the comment section. Please stay tuned to the channel, and of course, if you're new, don't forget to hit the subscribe button to get more updates when videos like this drops. Thanks and cheers.